going to get started here in just a minute. So everybody come on in and take a seat. And good morning, and thank you for being here. We're all really excited. So come on in and take a seat, everybody. Thank you.
Joe, good to see you. Good to see you.
Don't be bashful. Please come on in and find a seat up here right in front. Yeah.
Have a seat. Join us.
So, good morning, everyone. I'm just going to go ahead and kick off here so we can get to the fun event. So come on in and take a seat, and I'm just going to do some quick introductions, give a little background on how we got here today. So, good morning, everybody. Good morning. Good morning. Yeah, good morning. So it's going to be a fun day. So I'm Will Metcalf. I'm the Director of Research Development and Strategic Initiatives here at the University of Louisville. And welcome to the first ever founder hunt in our region. So this idea came out of a conversation with Charlie Miller and Patrick Henshaw, I don't know, about 2.5 months ago, right? And so the idea is we've got technologies at all of our regional universities, and U of L, UK, EKU, and often we've got great technologists, right? But we also need the business people, and that's why we've got you here today, to connect with the business people. And so this is a real partnership between the University of Louisville, the University of Kentucky, and the Commonwealth Commercialization Center. And so this wouldn't be possible without a guy like Brian Mefford back there with the vision that they had at the Cabinet for Economic Development. We kicked this whole thing off with the RISE effort about a year ago in December, on December 17th. And the idea was, how do we leverage, how does the Kentucky Cabinet for Economic Development do innovation and entrepreneurship support in a really thoughtful way, in a different way, leveraging the unique clusters of each region throughout the state to build an innovation economy, right? And so we knew that healthcare was a thing here in Louisville. We've got the Louisville Healthcare CEO Council, who's one of our sponsors today. Thank you, Tammy. And how do we leverage that and support an entrepreneurship, innovation-driven economy? And so this is a culmination of that. So we've got people here from all throughout the state, all throughout the region, other states, right? So we've got Ron Bunch here from Bowling Green. Thank you, Ron. We've got people from Pikeville, EKU. We've got Jared Arnett and his awesome team with Rusty Justice from Pikeville. We've got Kyle Keeney from Elevate Ventures. So this is a real regional event. We've got people from IU down today. We've got Med Institute today from Lafayette, Indiana. So people from all over the region here today to hear about these awesome healthcare technologies. And I want to thank, and this wouldn't be possible without our sponsors, so I want to thank our sponsors, TechStars, Larry Horn, thank you, Larry, PNC Bank with Chuck Denny and Tommy Wallace, and Frost Brown Todd. And so we've got some amazing sponsors, Round Tower, Louisville Healthcare CEO Council, our lead sponsor, and DMLO, the accounting firm, so thank you. We're going to have an awesome prize package to announce at the very end, so that's going to be an exciting announcement at the very end. And so, again, this is to drive and support an innovation, high-growth, high-tech economy. And I'm really thrilled to introduce somebody who really needs no introduction in this room. You all know him. He's done all kinds of businesses. He's got a pizza business all the way to one of the largest companies in the state. Signature Healthcare is the co-founder, CEO, and president of Signature Healthcare. So, Joe, come on up.
Thank you. So, I know the whole room pretty well, so just want to talk a little bit about where we are today, because we moved back here, almost 8.5 years ago, 9 years ago, and we were kind of dreaming of a day where we could really commercialize and start innovation. In our space right now, there's a need for innovation everywhere. From I don't care if it's workforce, technologies, telemedicine, telehealth, looking for a CMO. There's just so much going on. So originally as a kid, I'll just give you a quick story. I grew up here, and I'm 53 years old. So when I grew up, the entrepreneurship world was pretty dark. And it was I was at the end of the lifetime employment era where everybody wanted to be, you had to stay at a job forever. I remember quitting my job, my dad saying, "You're the biggest idiot." And I remember going around town, everybody, and when you quit your job back then and tried to do something, you lost all your friends. You were kind of by yourself at Kinko's wearing sunglasses. And I think about just how hard the lift was back then versus today. And so I remember just a little bit of social isolation of like, boy, if you leave corporate America and try to bootstrap something, it's painful. And today, what we're seeing, this event's an epic event, Will, I think, because first of all, when I was going to see U of L and UK partners, a huge thing. It was just a dream because I used to go to meetings, and I hate to say I love both places, but I really do. And I had to watch me say it's a cocktail party. So first of all, having you guys come together is a big deal for us because if the Commonwealth's going to win, it's going to be the whole city coming together. We're in about 41 locations across the state, one of the large employers, so we're from Pike County all the way across the state. And there's innovation needs everywhere across the state. So to get the university to come together, originally we moved back, we were trying to commercialize stuff with U of L, and today the infrastructure is there to do it. And what's great, if you've ever been around working with academic university research, that's a wide open space for all of us. So as a kid, I started out and dreamed of owning my own business, being a partner, and I think you learn lessons around that way, just from the tenacity and the doubling down. I think I had so many failures. Just to give you a list, I had a comedy wake-up service that was very famous to myself. And so I signed a deal with Showtime comedians, and I was the first one to ever in the country history to dial your house electronically with a demon dialer and wake your kids up while you were traveling with a joke. And so when I made Business First front page, I was working at an accounting firm. I remember coming to work that day and seeing it on the cover of Business First and throwing all the papers in the trash can so I get fired by Jim Radcliffe because he didn't on the side to get fired. And then I tried to do pizza as a kid where I thought if there's three things you need in your 20s, it was pizza, flowers, and beer. So I wanted all three at the same time. And so when I tried pizza with Jake's, we got killed, moved back in my parents' basement, and then ended up buying the local Beernos pizza. I learned local stuff matters. So if you live in your parents' basement a couple times and you lose your girlfriends and you're living on a concrete floor, all your friends are buying houses, you just learn a lot about focus and discipline and tenacity. And so you almost have to, at some point in your life, I think you almost got to stop keeping score. I think when you can't make it competitive because life's not competitive. I remember times where I had to just unplug the world and just go back in the lab and start, researching, doing new things. And so then we went through a lot of trial and tribulation. Now what's neat is we can spin out companies pretty quick. Our startup arm's getting better and better at Accenture. If you guys need a partner, you got something you think would change the aging care cluster, the CEO council coming together and unifying. I was at our meeting this week, the board meeting, never seen that many CEOs get along. And which toast to you, which is fantastic. But when you think about the power of the CEO council and that you have everybody unified on the aging care capital of the country, and then our biggest issue right now has been around workforce. So we think about medicine and innovation and research. At the same time, we have this enormous workplace issues and workforce issues. And so I know we're talking about social determinants coming into the workplace, and they really are, because right now we run about 17,000 employees with about 60% turnover, payrolls around 500 million, and just the level of anxiety on the workforce and how much we can do there in this room about making the workplace a totally different experience. I think we can master the innovation on healthcare and then understand social determinants are not a healthcare issue, they're actually a lifestyle issue, and bring them into the workplace. We got a lot of room, and that's one of the topics with the Microsoft grant we got recently. That's one of the focus studies. So, we were really excited about Will being your partner on this project. Obviously, we're a big fan of yours. I think it's an event to pull it together so fast and have you support not just CEO Council, not just Thrive, not just C3, just put together an array of solutions for the room that's going to be shared for all universities. It's just an exciting time for us to be here today. So, I think about you've done startups. Okay, good. So everybody agrees, Larry agrees, it's pretty lonely, right? At times, yeah. So I always think about, so the thing I've learned, a couple things, and I'll give you a couple of lessons that I think are important in my journey. I think the first thing I learned was, I hate to say it, sounds cliche, but you really, really can't give up. I've had so many businesses that were so close to the edge of going under, and then I found a breakthrough the next year, the next cycle. And I always think about, my wife will say, when are you ever going to be stable? And I always say never. because it just doesn't work that way. But I always think that you just got to gut things out so many times. And the world's moving so fast now, whatever we think is innovative today, somebody's copying 10 other places faster. And so I realized I had to get rid of old adages. I had to learn to be more open to change. But I think if we can find a way to be persistent and be supportive of each other. I think when you're in this room, you do startups, having a system, people that care about each other is a big deal. Second thing I learned along the way, I think is really important to us, is I should have brought more partners in faster. I think having partners matters. I used to want to try to control everything. I just think there's so many smart people. If we partner faster and let go of stuff in our ego, I think there's things we can do in this room as collective partnerships that are huge. I think I was so a control freak in my 20s that I realized I probably missed so many things by not being open to great partnerships and growing intellectually. I think partners help you grow faster. I think the other thing I think is really important for us is now that when I see somebody struggle in the paper or I see a negative article, I've had my own, I always want to write a letter or call them because I just think it's a heavy lift to be that kind of leader doing things transformative. And the mistake I made originally was I always want to be first. I was the first guy, very famous story, I'll impress you all. I was the first guy to do tuxedo delivery florist. I mean, how cool is that, right? I mean, why pay $60 to send flowers to your ex-girlfriend mad at you? In a hoodie, I brought in silver tray tuxedo delivery all across the city. I owned a chain called Leeds Florist. I was the first guy to have silver trays walking through lobbies with flowers and tuxedos. I was so famous it lasted for 18 months. But it was a great run. So I think when you think about change and what we go through, I think every failure I had, I got better with. I would tell you today, I've never been more proud of it. When I left the city years ago, I felt like Louisville didn't get it. I was a little frustrated with the startup community. I was frustrated with capital structures. But today, where we are as a city and the state, it's phenomenal. So, I look at Thrive or CEO Council, C3. There's a million ways to engage right now. And I would just tell you that in the next 5 to 6 years, this aging care capital is going to take off. This state can catch up and beat most states. And to have 2 universities come together and have U of L lead this event is a big day for me. So if you ever need anything, if you ever want to feel better, call me. I've got some terrible stories to tell you to make you feel better. I think sharing failure is always a good thing for all of us. I just want to tell you, it's been blessed to be back home in the community. It's been blessed to be civilly engaged with all these initiatives. And we are all in with you. I just pray for prosperity and success for all of us and just to really understand the journey and really engage and make this space special in Kentucky. So thanks so much.
So, Joe, we've got a very special gift for you here. It's
That won't last one race.
a giant bottle of Blanche. We're pretty frugal at U of L. So, not really, of course. We've got a full-size bottle to share today. So, yeah, thank you, Joe. It's amazing. I mean, it's just an inspirational story. Obviously, I mean, your track record is unparalleled. So, thank you so much. And so again, today we're here to talk about tech innovations. So we've got 9 pitches today. These are not pitches like normal business pitches though. We have inventor teams, so scientists, technologists, engineers, clinicians from U of L, UK, and Eastern Kentucky University. They're going to talk about their invention with the idea of connecting with the right business leads. It might be a large company, it might be a founder. We're trying to find people to help us grow these technologies and these innovations. So they're going to be 5-minute pitches. We've got a software here called Connections. There's instructions on your table. If you want to give real-time feedback, log in there and give feedback, pay attention. We're trying to improve this. We also are going to have a poster session afterwards. So there's going to be no questions during the presentation, but we're going to have a poster session where you can dig in about the technology and about the opportunity, talk to our tech transfer people about what that's going to be like, how do you license the technology, et cetera. So with that said, we're just going to kick it off here. Tommy, come on up. CT Fly.
Hi everyone and good morning. I just wanted to start off by saying how excited we are to be here. My name is Edward Brown and this is Dr. Tommy Roussel. Dr. Rizal is a professor at U of L Speed School of Engineering, and he's been working on commercializing technology for many years. He holds 8 patents and has been involved in 7 startup companies. Today we're going to present to you our invention for improving respiratory care. It's called Breathforce. So according to the CDC, COPD is the 3rd leading cause of death in the US, and more than 9% of people in Kentucky are affected. Additionally, people with spinal cord injury and other forms of paralysis show very high rates of cardiopulmonary dysfunction, and it's the leading cause of death in these patients. At the Kentucky Spinal Cord Injury Research Center, where I work, we have a collaborative research center where we have studied respiratory training in COPD and in spinal cord injury. We have published a pilot study on COPD, and we completed a National Institute of Health grant where we trained almost 40 patients with spinal cord injury. Both of those studies showed very promising results, but our experience did reveal some limitations with what is currently available. A lot of the current technology is crude and static and does not easily modulate the pressure threshold to meet the needs of the patients. Also, very few existing devices combine inspiratory and expiratory training. Additionally, there are not adequate data recording and diagnostic features in the current devices, and there are also limited customizable training protocols.
So as the engineer was brought onto the project, I inherited those problems. So we came up with our first generation device, which is called Breathforce. Star Wars had just come out, so the name kind of stuck. So what we do is we actually provide a method for the patients to actually do inspiration and expiration training, so the resistance is modulated while they breathe. The device is portable, you can use it at the house, but they're actually using it in the clinic, so the first generation device is being used by patients. And we've wrapped the software around this therapy that they provide. So it provides this unique therapy that's been developed by our partners, and we'll talk about them in a minute.
So what are some of the opportunities? Last year it was estimated that the respiratory care market topped $20 billion, and that is set to increase over 50% over the next 4 years. So in terms of applications, one of the most exciting things to us is that this technology actually goes beyond COPD and spinal cord injury. Those are just the 2 patient populations that we have directly worked with. This technology could expand to sleep disorders, asthma, pre- and post-operative care, weaning patients off of ventilators, and perhaps others. Also, in terms of access, this technology brings cutting-edge and advanced respiratory care into the home and allows for remote monitoring by physicians. Also, we know that we're onto something here, since that after the filing of our provisional patent, we were contacted by 4 established industry players to talk to us about licensing our technology.
So our team really consists of myself. I've been really focused on translational engineering for the past several years. Alex Ovechkin invented the therapy that's used. Eddie is our project manager. We do have a full-time research engineer as well as a PhD student working on the project. What's missing up here is a founder, somebody that can help us commercialize this technology. Go ahead. So we do have an international patent that's been filed earlier this year, and we have additional patent that's being filed here in the next few weeks, actually. Like I said, our first generation device is actually in use at Fraser, and we did go through Launch It to do some customer discovery to make sure that, if we talk to some clinicians, that we're actually working on something that's needed in the market, and we did get some really good feedback. It's kind of guided. What you see there is actually the 2nd generation prototype. We have funding to work on that for the next year, so we're working on this system, this dynamic valve, and then we're looking into maybe SBIR with a partner through NIH, maybe the Heart, Lung, and Blood Institute. So we really appreciate y'all being here. We have a poster later, and look forward to the rest of the presentation. So thanks.
Hello everyone, my name is Eric Hartman. I'm Associate Director of New Ventures at UK Office Technology Commercialization. I am not Keith Pennypacker. Dr. Pennypacker has experienced a medical emergency and is not able to join us, so I'm going to pinch hit for his presentation today. So please hold the rotten tomatoes, we'll work our way through this together. So this is an artificial intelligence enabled platform for assessing stroke symptoms and helping to give actionable information to the physicians and therapists that are treating patients that have suffered a stroke. So the problem is not stroke. We are not solving stroke. What we are solving is the problem that no one knows at the time that someone has a stroke what the long-term side effects of that stroke will be. And those effects aren't known until it's too late. And so with this technology, the idea is that they would be able to take blood samples during standard routine therapy for a stroke, and they would be able to analyze those blood samples using current existing laboratory techniques followed by artificial intelligence, and the artificial intelligence algorithms would be able to provide that actionable information that physicians and therapists would be able to use to immediately provide better therapy, more targeted therapy, more personalized medicine to that patient to be able to lessen the long-term impacts of the stroke. So again, the blood samples that would be taken are, these are already standard of care. So they're already able to take these blood samples, they're already able to process this blood with the techniques that exist today in the market, the tools and techniques that are available in every hospital laboratory has the ability to process these samples, perhaps with a specialized tray or something along those lines to process the blood, but no new equipment, no new techniques. It's all the analysis that would be done off-site could be then fed back in to the patient or to the physician and therapists. So the opportunity is obviously huge. Stroke is a huge patient population, and unfortunately there are many, many strokes that occur every year. 800,000 strokes, we all know that they're big numbers. The unique opportunity here with the University of Kentucky is that the University of Kentucky has a biobank of these blood samples that have been accessed over the last several years. And they have a unique capability to collect more samples with those right now. So University of Kentucky is a unique strategic partner or university to develop this technology. The team, it's a multidisciplinary scientific team. So Dr. Pennypacker is a world leader in the area of stroke and is very, very knowledgeable about this. And I will tell you, the very first time that I met with Dr. Pennypacker in my office, I said, this all sounds great, but this sounds like science fiction that nobody would ever use. I said, you need to go do some customer discovery. Pulled out his cell phone and he called Dr. Frazier. Dr. Frazier, between seeing patients, talked to us on the phone and said, this is an absolute medical need. This would be actionable information. If we had this data today, I would change my clinical practice to be able to use the results that this technology is going to provide. Dr. Cheng is a bioinformatics expert at University of Kentucky, and he is here today and will be manning the poster. So if you have questions about this, please see him at the poster, and he'd be more than happy to talk with you as well. What we need is your face here. What we need are the business and non-technical people to surround this technology and be able to help this move forward. Milestones. So I guess the first thing to point out here is that with the first run of the artificial intelligence algorithms, this technology is very, very early. But with the first run of the artificial intelligence algorithm, they were actually to identify 6 new drug targets that they could potentially repurpose to solve problems in this space. So there's an immediate go-to-market strategy with that. They're planning an STTR submission in January, so this would be an NIH STTR, and then plan to move forward with commercialization. A company has already formed in preparation for this, which is called Cerelux, and that company will be the one that's applying for the SBIR grants. So with that, thank you very much.
Hello everybody, it's a pleasure to be here today. I'm Sucheta Telang. I'm a physician scientist at the University of Louisville, and my co-presenter Holly Clark is also a scientist. She's been working extensively with us from the technology transfer aspect of this group of compounds. So our goal is to treat cancer and hopefully cure it by inhibiting the metabolism of glucose in these tumors. Everyone in this room has probably been affected by cancer in one way or another. It's a huge problem. 40% of us, which is probably 1 in 3 of us, is probably going to be diagnosed with cancer at some point in our lifetimes. And even though diagnosis, preventive strategies, and treatment has really improved, there's still a huge gap. It's still the second major reason for death, and 10 million people die of cancer every year. Now, tumors, as you know, grow very quickly, and to do that, they need nutrition. And the main kind of nutrition that they depend upon is sugar or glucose. And what they do is that they use this glucose, eat it up, break it down into energy and building blocks to make new cells so that they can survive and grow and spread. Now, just to illustrate that point, over here on the right side is a PET CT scan. Now this is like, a lot of you have probably seen this study. It's probably the best and the most widely used test for trying to diagnose and to follow cancers. And a CT scan is done so that you can actually see where the tumor is. And then to do the PET scan, patients are injected with a radioactive form of glucose. And what you do is you follow the uptake of the glucose into the tumor. And as you can see in this patient, it's a picture of a patient with lung cancer. The darkness of the uptake shows that there's more, the darkness of the image shows that there's more uptake into the tumor. And if you can see, compared to the normal lung, which is around it, there's a huge amount of uptake in the tumor itself, which shows that they take up and eat a lot of glucose. So glucose metabolism in tumors is regulated by the PFK-FB enzymes. What we found in our studies over the years is that blocking these enzymes will actually suppress tumor growth and suppress the tumor glycolysis, in essence, choking their supply of food. And so what we've done is identify novel small molecule inhibitors which will inhibit these enzymes, and have found that these compounds will, 1, decrease tumor glycolysis and tumor growth very effectively. And because glucose uptake and use is so much higher than normal tissues, it actually doesn't have any toxic side effects on normal tissue body, so it's like a targeted agent. And in kind of very exciting new experiments that we've seen, we found that these drugs will actually decrease the bad immune cells which are present in tumors, and so they may be very effective in combination with the new immunotherapies that are out there.
The market for this technology is very large. As Dr. Telang has already mentioned, 1 in 3 of us will be affected by cancer. And although initial studies we've been using, mostly done in lung cancer, just as the PET scan in the previous slide showed, our other initial studies have shown that these inhibitors will work in a wide variety of cancers, not only solid tumors, but also the blood cancer, so leukemia, lymphoma, so there's a great potential there. Currently, there's no other glucose metabolism inhibitors in clinical use, so we are the first to enter this area. You'll be working with an outstanding team of researchers at the Brown Cancer Center.
Okay, you already met me. I have expertise in tumor metabolism. In between, the second one is Dr. John Trent, whose virtual screening program actually identified these inhibitors. He's a structural chemist. And over on the right side is Jason Chesney, who's the director of our cancer center and has a great deal of expertise in clinical trials, tumor metabolism as well, and also in immunotherapies, which is very important for the development of this compound now.
From a product point of view, the development of this technology was funded by one of U of L's translational grants, so it's been highly vetted by a team of business people outside in an external review board and also at the NIH. It's completed 3 rounds of optimization. It appears to be very potent and orally available. It's got a large IP portfolio, including US and foreign issued and pending applications. The next step include going forward in clinical trial. So we are looking for a founder or founders to work with this amazing team, help us to starve cancer. Thank you.
Hello everyone, I'm Clay Larkin. Very excited to be here today, glad that you all made it. By 2020, 50% of Americans could be at risk for osteoporosis. That means that next year alone, approximately 100 million Americans are at risk for fracturing. Bone biopsy technology currently lags behind the market demand, as there is no dedicated bone biopsy needle on the market. Biopsies done today are done using either a repurposed manual bone marrow biopsy needle or by using orthopedic bone drills. We do have imaging technology. The most advanced imaging technology we have thus far is called the DEXA scan. It can measure bone mineral density. However, even the most advanced imaging technologies cannot give us a completely accurate state of the metabolic state of bone. Bone biopsies are the gold standard in diagnosing of metabolic bone disease, yet the technology is simply found lacking. Our answer to this problem was to design a brand new dedicated bone biopsy needle. The design does contain a proprietary cutting edge as well as a 3-part design meant to streamline the insertion of the needle into the bone, the coring of the bone, and then the removal of the bone core. It is designed also to work in conjunction with a power drill that already exists on the market today. We have a 2-part design, or 2 things that I would like to emphasize is the size of it. So it needs to be large enough to preserve the microarchitecture of the bone, but it doesn't need to be so large that it causes undue trauma to the patient. The cutting edge is also very important because the way it is designed, we have hopefully eliminated the artifactual damage within the bone as well as thermal injury to the surrounding bone. Diagnosing bone disease is just diagnosing alone is currently a $544 million a year in the United States alone. Osteoporosis results in over 9 million fractures per year. For reference, that is approximately 1 fracture every 3 seconds. Treatment and pharmaceuticals of treatment for bone disease is a rapidly growing market, and it's because we have a very quickly aging population and a high prevalence of bone disease. We also have higher rates of cancer and obesity. Here are 2 current competitors that are on the market. Keep in mind that both of these needles were originally designed to do bone marrow, and so they were less interested in what it did to the actual bone. In blue, the Jamshini needle is a manual device. Fewer and fewer physicians are willing to be trained on it because it is rigorous. And then in the orange there, you do have a power drill device. It produces a very small bone core, and it also produces several artifacts within the core. Just to highlight our design and how it is different from what exists, we will use an electric drill. It is the correct size for what we need. There are no damage artifacts within the bone, and then it is designed specifically for bone. Our team, my formal training is in architecture and engineering. Dr. Rao is an associate professor of medicine at the University of Kentucky College of Medicine. She is also a practicing nephrologist with several years experience in bone biopsies. Dr. Lima is a scientist that works at the University of Kentucky Department of Nephrology. She works closely with clinicians to analyze bone data. And then Dr. Maluka is our chief of nephrology. He is a world-renowned expert in his field and has pioneered biopsy techniques and interpretations. So we need to expand our team. This is not an all-inclusive list, but it does get us a start. We need a technology partner, and what that means is we need someone precision engineering, instrumentation engineering. We are open to funding opportunities to continue research and development. Ideally, we would like someone within the medical device industry, somebody that has experience or knowledge with taking something from a prototype to market. And then I'll conclude with this. This is where we're at, where we're immediately going. So as I said, we are here to build our team.
We have received a provisional patent. We have multiple NDAs in place with multiple companies that we've already spoken with that have expressed interest in helping us get to prototyping. And then our next tangible goal is to get a working prototype so that we may begin functional analysis. Thank you.
Hi, I'm Lindsay Calderon. Thank you for allowing us to present today, and I'm presenting on behalf of Dr. Ningiri, my partner in crime that I say. So what we have done is we design compounds, and we're designing them to both treat and also diagnose reproductive cancers. So my problem slide is going to be a little bit different than most of the people that presented before me. It's my daughter, right? And most of us that are parents, we want to protect our children, especially our daughters, right, against everything and anything. And one of the things that we're worried about is when they start to drive, right? Girls driving. And so if you look at the numbers though, she's 10 times more likely to die from a reproductive cancer than from a mortality from a car incident. And women in the room, if you look around, 1 in 8 of us are probably going to be afflicted with breast cancer over our years. And if you total the numbers for reproductive cancer, it's about 500,000 people are afflicted each year. And if you get a rare disease state cancer such as triple negative or metastatic ovarian, your rates of mortality increase exponentially. So our way to solve this or help society basically defeat these cancers is to perfect what's already on the market. So currently there are platinum compounds. There are 2 major ones that are used, cisplatin and carboplatin. Carboplatin was a spin-off because cisplatin was so toxic. Now, what we did was we took cisplatin, the toxic one, and we changed the structure a little bit. And so right here on our compound that has already been patented, up here at the top is the platinum compound. Now, the structure, when we changed it, looks like carboplatin, so it's going to be more effective and also has a safety profile. Then we designed a linker to a hormone, and that hormone, what it will do is it will drag it to the cancer that is expressing the receptor for it. So there's a 2-fold safety profile on this, and we've seen 20-fold increase getting into triple negative breast cancer cells. And when it gets in, it's cleaved, and it will revert back to the cisplatin compound. And so we did in vivo trials in mice, and in the black is normal tumor growth, in the blue is carboplatin that's used, and in the red is our compound, totally decreasing the amount of cancer growth for 2 weeks. And so the opportunity is extremely large. These compounds are used if you've had cancer. It's probably been one of the ones recommended for you, and they're constantly being used, especially for end stage. And if you look at triple negative and metastatic and then resistant to cisplatin, it should work as well. And these cancers, you have a 77 to 75% mortality rate, and hopefully this compound should be able to use against it. So this is our company platform. We just didn't focus on one compound. We thought, man, if we can make these linkers and we can perfect this, let's do it for others. So our first compound is up here. Patent's been issued. And we're also looking to make sure that we can diagnose it as a pro-drug status for these orphan drug states. And we're able to do that already. We just have to do it in the animal model. We also have 2 other compounds. One's an antioxidant and the other one is cytotoxic, both based on the linker and the LRH targeting. And then the other 2 down here are diagnostic. So nicely, the professors before us showed you PET scans. Those PET scans are successful based on the nucleotides that you use. And if you have a targeting one, you're going to have clear images and you're going to be able to localize smaller colonies quicker and faster and diagnose those patients earlier and get them treatments. And so we're writing the provisional patent currently, and hopefully in 2 weeks we will have that filed. And so this is our team, Dr. Ningiri and myself. I'm a pharmacologist, she's a synthetic chemist, so I say we're the perfect partners in crime, diagnosing cancers and also trying to figure out how to make new compounds towards them. Dr. Kilgore is a longtime mentor of mine. He focuses on treating breast cancer specifically and looking at targeting of them with different compounds. And Dr. Thorson has been absolutely wonderful. He's the director of innovation at UK and also drug discovery and works with Markey Cancer Center. And so what we're looking for is anyone that has business in biopharma, startup companies, or regulatory expertise. Thank you very much.
Morning, everyone. Thank you for this opportunity to present eye lobes, which can imaging the brain tumor fluorescence signals, which help identify the tumor margins like during the surgery. I'm Guo Cheng Yu. I'm a faculty at the Department of Biomedical Engineering. We have worked on this project since like 2018. The problem is, as you can see, there are estimates like 700,000 Americans living with a brain tumor. So this is a big problem. You know, the brain tumor is a critical tumor which could, in fact, not only cause a death, but also in fact, a lot of problems like disabled people and a lot of complications of the treatment. So the major treatment is the surgical removal of the brain tumors. However, the difficult part is the brain tumors introvert to the brain tissues without a very clear margin. So it's a diffuse tumor usually. So it's very critical to identify the tumor during the surgery. And currently, practical method is using the fluorescence imaging dye to enhance the tumor margins during the surgery. So this showing the microscope using in the clinic. So like the surgeon actually operate this big microscope with ability to for the fluorescence imaging. However, you can see here, so this is a huge device, and it's not easy to operate, right? Especially when you remove the tiny tumor in the brain, so it's really not convenient. So the surgeon, Dr. Peterman, actually, this is not Dr. Peterman, but he actually approached us and asked us, can you make something really like a portable device? Because this is Dr. Peterman. He actually usually wear this type of eye lobes with some magnification when they he operate in the clinical room, right? So this is very convenient, and this is with like optical fiber coupled with a light, and then also well, they wear this devices, they can easily free their hand, right, to remove the tumor. So, but however, the problem with this device is they don't have the ability to look at the fluorescence signal. So, and our solution is like, okay, so we actually integrate the light source to excite the fluorescence dye, and also has optical filters integrated with the light lobes. And also we actually integrate a camera with filters. We can actually record the operation procedures and commence with the biopsies after the surgery, right? Remove the tumor. So the advantage of this device is you can see here, very comfortable, compact, small, and easy to align, maintain, and use, and also inexpensive, right? Like 40 times less than the conventional microscope. And its potential also provide a higher emission and greater visualization with this device, because we can optimize the wavelengths, right, of the light excitation. So opportunities, the surgical operative microscope market is really growing. According to the literatures, so it has like $1.3 billion market for this microscope by 2024. So we actually expected that with our eye lobes, we can actually have this hundreds of millions marketing in United States alone. And then particularly this device can be used in a military mobile hospital, right, because it's so powerful. And the milestones and current status, So we have received a phase 2 STTR grant in September of this year. And then we have built a prototype device, as I showed you previously. And we have got some prelim data on the patient. And since the proof of concept goes through it, and it's really effective. And we actually also has an international patent filed by the University of Kentucky. And so our team, we actually has interim CEO, also the founder of this small company, Biopsy. And this is me and a research scientist work in this company, and also University of Kentucky for the technology development. And Dr. Peterman is a world well-known neurosurgeon, help us to test this device. So our next step is we're going to build up our team. We need more management experienced people join our team. And also we actually try to validate and further develop this device. And we try to apply a follow-up like a phase 2 grant. And of course we're looking for the industry collaborations, because we really need someone has experience to help us to build up pre-manufactured products so that we can put into the market. Thank you very much.
Hi, my name is Kayla, and I'm with the University of Louisville's Commercialization Epicenter, and it is my pleasure to be here today with Dr. Harnett, presenting what I believe to be the next generation of flexible sensors and soft electronics. From our smartphones to our smartwatches, electronics are being integrated into all aspects of our life. And the key point of this integration are the sensors. Dr. Harnett is doing what no one else is doing. She's creating durable, waterproof, soft electronics.
So you're all familiar with wearables in terms of watches, and phones are somewhat wearable, but they don't do certain things that the human body does. Our bodies bend, they stretch, they twist, and if you're aware of trends in robotics, if you're thinking about movies, Big Hero 6 with Baymax, we're considering soft inflatable robots for interacting safely with humans in healthcare situations. And all of those are soft and flexible and not brittle and breakable objects. So manufacturers need some kinds of sensors that can go out onto these soft and squishy formats. And things that we would like to get out of those are mapping. Where is somebody pressing on the robot or on your arm? Sensing patterns, sensing dynamics of motion, and collecting that data wirelessly. Our technology solution uses optics. We have a stretchable kind of gummy bear-like material that we developed that if you pull on it, you get less light transmission. Your light just has to bounce more times through this waveguide. It's really a stretchable optical fiber. And we've also developed some electronic materials that help integrate these with soft materials. We can sew them in, and we can cast them into silicone membranes that are used in soft robotics and get health information out, such as weight bearing on this leg right here. So this is the material.
So the applications here are truly limitless. I'll give you an example just to give you something to wrap your head around. So say that a football player has sensors embedded in a mesh cap that he or she wears under their football helmet. Now these sensors would be able to, through the use of an accelerometer, know what forces are being placed on the player in a head-to-head collision. Now, there are already companies in the market doing just that. But I'll tell you what their sensors cannot do that Dr. Harnett's can do. They cannot send that signal wirelessly to the sports therapist on the sideline where they see on their device that that concussion or that impact may be in range for a mild concussion or potentially brain injury. That simple analysis could be the difference between saving their life or not. And that's just one example. From rehab, you going to PT after you have an ACL tear, and now your physical therapist can send you home with a smart brace that has sensors, seeing how your muscles are coming back, rehabilitating, and if other muscles are compensating for that injury. To sports, we want to know how that person went so fast, jumped so high, or how they recovered after an intense game or practice. This could revolutionize sports as well. And then lastly, robotics. The next big industrial boom will be us in robotics, working together side by side. And how will we teach them to do things that we do? To move how we do, pick things up how we do, we need sensors that are flexible and sensitive and durable. This market has a huge opportunity, and it's a multi-billion-dollar business that demands creative innovators and entrepreneurs.
I've been working in the sensors area for most of my career. Laboratory teams have been working on lab-on-the-chip systems and soft sensors and the electronics to drive them. So what you would get out of collaborating with us is materials that aren't commercially available and the electronics and the means of getting that data out. What we're looking for is somebody who's entrepreneurial and can take this technology to the next level in healthcare, sports medicine, and biomedicine. Thank you.
To date, not yet. To date, we have 2 issued patents and an immense patent portfolio growing every year thanks to Cindy's research and her lab. 6 patents pending internationally and in the US. She received 2 sponsored research agreements this year through our marketing efforts with global partners interested in using her technology. And lastly, she's a part of 2 highly federally funded grant projects that will begin in 2020 with collaborative teams that, one, are using this platform with machine learning, taking the inputs of Cindy's data and mapping them, data collecting, and providing artificial intelligence. And the other project is for use in robotics. Thank you so much, and we look forward to talking with you at the poster presentation.
All right, hello. I am Janelle Malloy. I'm a professor of medical physics at the University of Kentucky Department of Radiation Medicine. And I, along with my colleagues, have developed an innovation to make a quality assurance of radiation therapy faster and better. So, we all know cancer is an awful disease. A lot of us are going to be impacted by it. But a lot of patients who suffer from cancer can be treated with radiation. Now, radiation oftentimes is delivered using these large machines called linear accelerators. These things are complicated. Quite frankly, they're a little bit dangerous, but they're incredibly precise. Linear accelerator is shown here, and you can see that it's hitting the tumor tissue while it's avoiding the nice, normal, healthy tissue, which is what we want to do. What's the problem, though? This slide is deliberately complicated because the quality assurance procedures that we have to do are very complicated. All of those devices right there are the devices that we have to walk in and out of the room and set them up, and that's the time-consuming part of doing all of this quality assurance. Hospitals spend a lot of money buying these complicated pieces of equipment. All of these tables right here are the industry standards for the amount of QA data that you have to take. It's literally hundreds of separate measurements. And I have watched my staff spend 8 hours to complete these tasks. And so you can see why literally you might need a physicist in order to be able to do this. Well, the innovation that we have developed at the University of Kentucky is something that we're calling the QA solver. It takes all of those pieces of equipment that you saw and consolidates them into one device. And the big thing that that does is that it prevents people from having to go in and out of the room and saves a lot of time. It's going to save hospitals and clinics money because they're only buying one device instead of a whole bunch. And because it's easy to set up, it's a single device, and all of the data collection is automated and it's presented in a very visually accessible, intuitive manner. This can be done by, say, a radiation therapist rather than a costly and scarce medical physicist. So, what's the opportunity? As I said, in addition to saving hospitals and clinics money in terms of having to buy equipment and paying expensive people to do these things, because the data is collected automatically and presented intuitively, all of this data can be uploaded to the cloud. And because of that, the medical physicist does not have to physically be in the room taking this data, but they can be sitting here maybe on the beach in Florida, reviewing the results from up in Idaho, Arizona, Kentucky. This whole concept is near and dear to my heart, and I'm glad that some of you already talked about the fact that we're here in Kentucky. We have some great medical centers, a lot of big cities. We also have a lot of rural areas. And we work with partners that have the money and they have a lot of the resources to deliver radiation therapy, but one of the hardest things that they face is getting medical physics support in order to maintain these machines. If you can allow these complicated machines to have their quality assurance done by a qualified medical physicist who doesn't have to physically be there, that is a game changer in our field. We estimated that there's about a $825 million total addressable market in the U.S. and expecting about 20% growth by 2028, only in the U.S. You start adding in global uses for this and that number can become even larger. We have a few viable competitors out there, but none of them consolidate and integrate and allow the remote review like our device does. So obviously I'm going to give you a graph that shows all of the check marks in our, in our column, right? I passed that one. All right, we have an awesome team. I put myself there, I'm the Director of Medical Physics there, but the real reason that I'm important is because the entire medical physics staff at the University of Kentucky has helped to develop this and test this. We have multiple PhDs in medical physics, engineers, programmers. John Braff is our engineer who has been working with us for a couple of years now. Bill O'Brien is our marketing strategist, he's over here. And Dave Hassler is our CFO who's done a lot of financial modeling for us. I need to wrap it up here. We've done proof of concept on all the components. This thing is real and it does work. We're filing an omnibus patent both internationally and in the US. And we are in negotiations with our first clinical partner, Medical Physics Private Practice Group down in Arkansas. So anyway, we would love to have somebody join us who has business expertise and a lot of passion. And I thank you.
Well, good afternoon. I'm Josh Nichols. I'm excited to tell you a little bit about a diabetic retinopathy diagnostic. Briefly about myself, I am a serial CEO and co-founder. I have about 20 years of experience with venture-backed companies. I also work with the University of Louisville through the LEAP program, Cincy Tech, which is a venture fund out of Cincinnati, and also lead a company, the Cleveland Clinic. So, diabetic retinopathy. Diabetes is a huge problem and it has more than quadrupled over the last 30 years. It's a disease that has significant comorbidities associated with it. Heart disease, kidney disease, decubitus ulcers, and of course diabetic retinopathy. Diabetic retinopathy is a vision-threatening disease whereby these patients can lose their eyesight as a result of exuberant growth of vasculature within the retina. The problem is, like a lot of things, that the earlier that you can detect it, the likelihood that you can improve the outcome for those patients. And this is true. Right now, patients are diagnosed essentially a two-dimensional retina. That is something that can be done in most ocular settings. However, using a technology called optical coherence tomography, you actually get a three-dimensional picture of that patient's retina. And you can detect and identify these subtle nuances that can prevent later stage diabetic retinopathy and vision loss. So the technology that was developed at the University of Louisville was led by Ayman Al-Baz and his research group. And it's composed of using machine learning adjacent to optical coherence tomography. And they have conducted a clinical study that gives insight into a cohort of patients and found significantly concordance with their AI technology and the ability to detect. Something I think is a really interesting anecdote from that study was that within the normal population of non-diabetic patients, they actually found 2 patients out of 100 that had early stage diabetic retinopathy that were not otherwise diagnosed previously as diabetes patients. So it's a very powerful technology. This exists within the field of AI and AI's application to healthcare, and that is expected to more than double over the next 5 years. So it's a significant opportunity of about $1.3 billion in the not too distant future. The team that developed this, again, is the Al-Baz research group here. I think it's a real gem, and there's other technologies I'll briefly mention here that can be part of a platform. The technology has also been validated by clinicians who work alongside and have provided an understanding of the value and the potential of this technology within healthcare. The technology has been supported by both grants internal to the University of Louisville as well as the Culture Foundation. It's been a very proactive effort to continue to patent and protect this technology. Before I go there, just in the last week, there's been some really exciting advances in this, in the commercial realm. So there has been outreach from the part of an OCT manufacturer that said we really need to have an AI technology to pair with our device. It gives us a competitive advantage in the market. And this is now positioned to work adjacent to that company, perhaps their joint venture, perhaps as a new startup company, with backing from an SBIR opportunity that this company has sought and gained, and then move forward together with that funding and then some outside investment. So it's really in a neat position. Love to talk with you about it more if you have an interest in this or any of the U of L technologies. Thank you.
All right, thank you. So that's the end of our formal program. We're going to have a poster session here, right here on your left, where you can talk to the inventors and the technologists and the engineers and the teams, dig into it, see if there's anything you're interested in. I want to thank our sponsors again. You know, Round Tower, I mean, this wouldn't be possible without them. So Round Tower, Louisville Healthcare CEO Council, Frost Brown Todd, Med Institute, DMLO, and I do want to call it specifically for a company that licenses. So if someone licenses any of the technologies that were presented here today and mentions this event, they're going to get a prize package worth about $15,000. So we've got $10,000 from Med Institute and Engineering and Regulatory Services. So Med Institute is a division of Cook Group, which is the largest largest privately held medical device manufacturing company in the world. So it's top-notch precision engineering support. We have DMLO, the accounting firm. They donated $1,200 worth of accounting services. So very excited about that. And then we have Frost Brown Todd, who's donated $2,000 worth of legal services. So you basically have the start of a really good company here. If you license a piece of technology within a year, one of these technologies here can be mentioned in this event. So, you know, it's a great opportunity. Thank you. Yeah.
One package available.
Yeah, so one package available. So first license, so it's kind of a race to the finish line here. And I do want to call out Mike DeCenzo. So this is the end of Startup Week. This is the culmination and the cap of Startup Week here in Louisville. This is our first TechStar Startup Week. It was an amazing week, a ton of really high impact presentations and events and talks. So thank you, Mike, for that. And all the volunteers that supported this event and all the events throughout Startup Week wouldn't happen without the volunteers and our sponsors. And again, back to the Cabinet for Economic Development for the vision a year ago to make a big change in the way we support entrepreneurship and innovation. And so I see Terry Gill back there. Terry's leadership and vision was a big part of that. And so I want to just say thank you to Terry as well. note, so again, the Connections app, if you had not reviewed or did the live streaming and updating and rating of the presentations, go in now and go ahead and rate the presentations for us and give feedback. We're excited to do that. And now we're going to have live racing starting at 1. We're going to have lunch. It's going to be laid out here pretty soon. So go into the poster sessions, talk to the inventor teams. We're going to have lunch and then hang out the rest of the day and talk about business and build businesses together. So thank you.